Thank you very much for this opportunity to show you some of our technologies and what we can do with those. My name is Aditya Mathur. I'm the founding center director of iTrust here at the Singapore University of Technology and Design. And currently, I am director of National Satellite of Excellence. Today's demo is being done from here from iTrust at SUTD. The objective of this demo is to show you how physical plants such as the water treatment plant, electric power plant, ships, ports, etc. can be attacked remotely by adversaries. The demo today makes an assumption that such attacks are possible when the adversary has access to the plant. Now, this access can be obtained in a variety of ways. There are at least 3 types of accesses. One is a remote access through the internet. That's the one we'll be using today, and we have given you that access. The other is direct access from inside the plant, and that would be an access for an insider. And the third one is a mix of insider and remote access, which could happen when there's a contractor that comes into the plant and on purpose or by mistake, the contractor attaches the laptop to the plant and a malware is injected into the plant computers, and that malware somehow allows an internet connection between the plant and an adversary. So there are several possible scenarios that exist using which an attacker can launch an attack on a physical plant. Again, today's attack assumes that the adversary has access to the plant through the internet. So before we do the demo, I would like to introduce you to the members of the team who have spent a lot of time to get this demo set up. So I'll first introduce you to Mr. Siddhant. Siddhant Srivastav has been with us for several years now, and he has been leading this demo. He has developed quite a few technologies in iTrust, and today he will lead this demo and show you how the attacks are launched on this plant. We have Joel. Joel, can you come over? Okay. Joel has recently joined us. He's an SUTD graduate, and Joel has assisted Siddhant in setting up this demo. We have Andrew, who has been with us for quite some time now. Andrew is one of our plant engineers, and he also has helped Siddhant in setting up this demo. And right here we have Anand, who is also one of our plant engineers, who helps us in setting up this demo. So with that introduction, I will now give the mic to Siddhant, and he will lead you through this entire demo. Thank you very much.
Thank you. Greetings, everyone. As we go through this demo, I'll firstly walk you through the different systems of the plant. So we have 2 different systems here. First, we have the SWaT SCADA system in front of you, and I'll be using the annotate feature of Zoom to make sure that we are looking at the same things. So for example, the first attack that we launch will be on the first stage, which is the raw water stage of the plant, which you see right here. The second attack will be on the pre-treatment stage or the chemical dosing stage, which will be on the second stage of the attack among these particular components, which are full of chemicals. So these 2 attacks will comprise the demonstration that is about to follow. Simultaneously, I'll also be pointing to the CCTV feed and also be annotating that. And as you can see, the water level is currently around 900 liters in this stage, as also indicated by the black tape that you see on the screen. So before starting the attack, it's important to note that the 900 liters on the tank is corresponding to 662 millimeter on the raw water LIT 101 meter, and these 2 values are equivalent. So the millimeter value here is equivalent to the liter value on the tank. So now we'll be starting the first attack that we have. The first attack focuses on the raw water stage of the plant. So we'll focus on the raw water stage, which comprises of primarily the following components. There's a flow meter on the left, which currently shows 0 because there's no water flowing through the pipe because the valve is closed. The valve itself, which is MV101, which when is open, allows water to flow into the tank. There's a letter next to the valve, which is A, which basically means that the valve is in automatic mode, and that means that the plant is currently being controlled by the control logic or the plant logic for the plant. So all the safety conditions and all the different conditions for normal operation of the plant are governing the behavior of valves and different pumps, etc. On the right, we see P101, which is a pump which is pumping water out of the plant. That's why we see the water level is decreasing currently. So the attack is very simple. The attack basically will turn this valve open regardless of the rest of the components. So as soon as the valve is turned open, the water will now start flowing into the tank, and as a result the water level will start rising, and in case the pumps are turned off, the water level in the tank will keep rising and the tank will overflow. So the visual indicators for that is that the red pump will turn green and the A will turn to M, which stands for manual mode. Also, we'll see that the flow meter will show a value close to 2.5 meter cube per hour, which is the flow of the water through the pipes. So as soon as you're ready, you can launch the attack from the attack desk in front of you. So as we can see, the valve has been turned to manual mode, and the red valve is currently turning green, and the water level in the flow meter is also showing 2.5. Now we'll see the LIT101 value stabilize around 569 because there's water flowing in, which is much higher than the water flowing out. So we'll see a gradual rise in LIT101's value because the pump is also simultaneously trying to pump out the water. So in this particular case, if the water level rises beyond a certain point, as you can see in the screen, there's a lot of turbulence on the CCTV screen in the water level of the tank. Beyond a point, if this is left unchecked, the water level will rise to all these different set points that you see on the CCTV screen. For example, the 1200 liter set point, the 1600 liter set point, and beyond a point, the water will overflow. So we can already see that the water level is higher than from where we started. And if remained unchecked, this water level will go beyond 600 millimeter in a few seconds to all the rest of the values, which will basically result in flooding. And this kind of an attack has also been carried out in real life events. So this is a replica of many attacks which have been implemented in the real world plants as well. So we can see the water level is now at 606, and the tank is also crossing beyond the black tape level. And if we don't stop the attack, the water level would eventually overflow. So now we'll stop the attack and move on to the next attack. So when we stop the attack, it will take some time to stabilize. So as soon as we stop the attack, we'll see the valve change from green back to red and the M change back from M to A, as we see right in front of us. So we can see that the water motorized valve is now turning back from green to red. So it's going back from open to close. So now that that's complete, we can move to the next stage, which is the chemical treatment stage. So when we go to the pre-treatment stage, this particular attack focuses on the HCl dosing pump, which will intentionally focus on increasing the acidity of the water level through a chemical injection attack. So the main components to look out for in this stage are P203. So as we launch the attack, we'll see that the A corresponding to this pump will turn to M, and even if the pump was programmed to be off, it will turn on. And as soon as that happens, we'll see that the pH meter will result in a decreasing value beyond the current decrease that you see right now. So as soon as you're ready, you can start the attack. So this attack takes some time to propagate. We see all the pumps have turned to red according to plant logic. Now we'll see as soon as the attack is launched, the A will turn to M and the pump will turn to green eventually. So we can see that the automatic mode has changed to M, and P203, which is the HCl dosing pump, will slowly turn to green. So because the pump is still red, we see the pH meter rising in value, which means increasing in the basic nature of the plant. And as soon as the HCl dosing pump turns green, the attack will start, and that will affect the pH meter. So as we can see in this particular attack, the pumps have turned green as well as the valve, which has also opened. So this results in a constant decrease in pH value, as we can see from 10.08 to 10.07, 06, and so on. So as this continues, we'll see that the water level will become increasingly acidic, and if it becomes acidic beyond a point, it will become unsafe for like human consumption as well as industrial use cases. And this is a replica of the Florida water treatment plant attack, which happened a couple of years ago. So this is also a replica of a real world attack, and like we can see how easy it is to inject chemicals into the pump by just turning one pump and one valve from automatic to manual mode and opening it. So we can see the pH reach 9 in front of us, from 10.01 to 9 soon. And you can also see on the CCTV screen that the pumps corresponding to it are blinking green. And because of that, we can see that constant amounts of chemicals are being injected every second. So we can see that the pH is now reached 9.96, 9.95, and if this goes unchecked, the pH will go below 7, and at that point the water will become too acidic for the rest of the stages. So it can even damage the membranes of the ultrafiltration stage and the rest of the stages. So this attack will have a cascading impact on the rest of the stages as well. So these were the two attacks that we wanted to demonstrate. And like if you want, you can stop the attack right now. The impact of that will be that the manual mode will turn to automatic mode, both for the P203 pump as well as the MV201 valve. So yeah, as soon as you press the button, it will reset the stage back to its automatic values, and the plant logic will take over. Yeah, so we can see that the plant's stage 2 components have changed to automatic mode. So the pumps have turned to red, which signifies the stop state for the pump. So the pump has stopped and the valve has closed. So now there's no acidic water flowing through this stage and no more chemicals being injected through this stage. So this signifies that the plant is back to its automatic operation and the plant logic has been issued in effect. So these were the two demonstrations that we wanted to share with you. If there are any comments or questions, we'll be happy to respond to them. Thank you, everyone. That's it for the demo.